right, so I've just started the recording and, by continuing to be in this meeting, you are consenting to be recorded. So welcome to our second webinar of the course, and this is going to be for module 1. So the very first one for the course that you are currently on, Data 460. And a wonderful topic of NLP, the most exciting, I would say, at least especially in the recent times. So we'll see what we're going to talk about here. Of course, I'm just going to, again, skip the educates part of it. We have a small crowd here, so please feel free to chime in, jump in with questions, stop me anytime. Don't have to wait towards the end, okay, on any slide. Absolutely. And so we'll first touch base on NLP, and of course I'll try to steer away and keep away from whatever you would have learned or read in the coursework. I'm going to avoid that, but just supplement it in some way or bring it up some part of it just as a refresher here and just to tie it up with what I want to kind of add on to what we have. But we'll just not too much delving into it, but trying to get to some of the important parts of NLP, which is becoming one of the most exciting fields in recent times. Then we'll talk about the assignment 1, and this is the one that you'd be working on during this class week. And then I'll open it up for your questions. And once again, as I said, you can jump in at any point in time. We have a small crowd here today. So, hey, welcome, Chase. We just got started, and I'm just laying out today's agenda. Okay, alrighty. Okay, so with that, let's jump into or before I kind of jump into our NLP, our main topic here, just a little retrospective. Yes, and I just want to mention that this has been one of the most exciting discussion weeks that I've seen in recent times. Not just this course, but the previous courses that I've been part of and you've been part of. Yeah, so keep up the good work, folks. Really, I mean, I saw there was a lot of chatter, and especially some of you have put in your thoughts and comments much ahead of time, which was really very helpful. And I saw there's going back and forth with and responding to your classmates, to me as well, to my responses to your post. So let's keep this going. As I said, there's a lot that we can learn from each other, a lot that we could learn by talking to each other, discussing this topic, which, as I said, is one of the most exciting topics. So yeah, let's hopefully the next discussions, or the next 3 discussions that we have, are going to be as exciting as this one. Many of you, as I just mentioned, you've embraced the spirit of engagement, you participated well, you reviewed your classmates' posting, you asked good questions, you commented well. Some of you're pretty good with commenting and really encouraging your classmates, with your positive comments to them and asking some very good questions. So let's keep up with that. Okay, please do not lose momentum. As a matter of fact, we want to kind of gain more momentum, and as I always keep saying, we want to hit to the gold standard. And again, I know Chase and Erin, you're already taking advantage of these webinars, but the folks kind of watching this recording, I would highly suggest that you attend these webinars. If you cannot, watch the recordings of these webinars. Very important, because there could be things that your folks participating here could be asking questions that, in case you're not here live, you'll at least hear the answers to those questions. Maybe those are the things on your mind as well, or maybe those are the questions, concerns that you have that can get resolved here or being asked by your classmates that you want to really listen to. Okay. And so with that, talking about NLP, we're talking about language. Let's first think about what humans are talking about, human beings, us. How are we with the language, right? So first and foremost, let's look at the left-hand side, right? So we are good at ambiguity, right? If the language, if we are very good with filling in the blanks, if you will, right? Based on what you're trying to speak, I could probably decipher. You could just say two words, and probably I'll make up, or same thing for anyone here, right? We're pretty good with that. We know what could be coming in next. We know how to fill in the blanks at times. We sometimes even just based on how people are watching or looking at you or by their expressions, you could really, decipher or process what they could be they're trying to tell you, right? So that ambiguity is, we are really good with that. Creativity too. I mean, we can be so creative with our language, the way we speak, how creative we become when we're talking, especially to our friends or to our family, and at times, those code languages, those little signs, or the way we twist our language, the words, the special words that we come up with to make things more, kind of private, if you will, or make it interesting between friends. So we're pretty good with that. We always have done that. Every generation that you can think of have come up with their own kind of a language that they speak with each other, especially amongst friends, right? Among friends and families, there's different ways that people talk and how creative they become. Even the slang is being creative with the language itself, right? If you think about it positively, it's a creativity. Then a lot of things is based on common knowledge that we will apply in the language. Like if I tell you something, maybe get me this, or get me butter. You know that you're getting butter from. You will relate it to saying, okay, if you're at home, you mean you want to get into the refrigerator, or maybe in the kitchen table, or wherever. You can have you can relate common knowledge to what you're trying to speak, or what you're trying to ask, or what should be your response to that, right? Maybe sometimes you don't want to even say the entire sentence, and again, ambiguity, right? You can fill in that sentence. So if you're in the house, and if I tell you to get me butter, you're getting butter from the kitchen table or from the refrigerator. I don't have to say, go get the butter from the refrigerator, right? So again, ambiguity, common knowledge, leads to even some creativity that happens in the way. Diversity, the way we talk to people, right? As I said, when talking to friends, your tone and your language with friends, your tone and language with your parents, with your siblings, with your coworkers, with your, as a someone with your classmates. I mean, that diversity, you would change your language, your responses, the way you'd react to everything based on who you're speaking with, right? So we are good with that. Just by seeing who is in front of us, we can change our tone and languages accordingly. And when I say language, doesn't mean we change completely different language. It's just maybe the use of vocabulary, right? And the way we would speak things, or way we would want to maybe shorten sentences, or maybe long sentences, whatever. We change a lot if you think about it, right? If you think about it, how you kind of talk to different sets and groups of people is so different. Empathy, um, again, you know when to show empathy based on how things are being asked, or who you're talking to. You're talking to a young kid, or you're talking to someone who's much older than you, or at a very old age, and all of that, or when people have certain things going on in their life that make you empathize with them, right? So yeah, that way the way, again, your choice of words could be so different when you hear certain things at certain times from certain people at certain place, right? All of that together, right? Think about if somebody has to give you a very some bad news at work or at home. The way you empathize would be different, right? Your choice of words could be different. Analogies, right? Based on, again, we are so good with giving out providing analogies to our people based on, hey, let me tell you, if you want to explain to you something, you would want to find out an analogy that could resonate with that person. If a young kid asks you about computer science, about it, what's a database? When you're and this sometimes these are some of the interview questions also, right? Hey, explain a database to a 5-year-old, right? Why do you think they ask the question? It's because they want to see how you are explaining, how you could go down to the level of a kid and explain it in those words, in that terms, that it could be very easy to understand. um, Sometimes we say things and it's so at such a high technical level that you can get away with saying, okay, yeah, I told you what's a definition of database. I don't want that. Tell it to a kid and try to explain it to them so they will understand. But anyway, so you give analogies, right? When you're trying to tell a kid what a database is, you would say, hey, you have a cupboard at home, you have a shelf, you have all those different shelves, and you put different things in these shelves. You have shirts, you have a shelf for shirt, you have a shelf for this. So you would tell a kid this way, you'd give analogies, and you know how to do that, right? You're good with storytelling. You would kind of know how to weave a story and how to present it. Even your own presentations, when you're giving out your presentations at work, at school, and in your classroom, in your how you'd kind of tell a story. It's you know what, again, the choice of words, right? What we are not so good at is the speed, right? When it comes to speed, right? Speed reading. Yes, we can read fast. Yes, some of us are fast readers, but how fast, right? Again, there's going to be some limitation. There's going to be some limitation on how fast we can write, and some limitation on how fast we can comprehend, right? If someone is a very fast speaker like me, sometimes I talk so fast and I have to kind of be conscious of that fact, and I have to say, okay, slow down, Lanesh. But anyway, my point is that I'm going to lose my audience, right? And the reason is that the person is not going to be able to comprehend that fast. Anybody or anyone, like if you're a fast speaker, again, you're watching a video even and you're listening to something, you just increase the speed, you double the speed, triple the speed. Are you able to remember everything? Even reading, you read so fast, at the end of it you feel like, oh, I read the entire page, but I did not understand what I read. So again, we're not good with that speed. We're not so good at multiple languages too, right? Again, there are people who read, write multiple languages. Again, finite number, single digit, very few with double digits. Have you heard of anyone with triple digits, knowing hundreds of languages? I've never. And I don't know if anybody. Maybe if there is, maybe they're just making a building as a world record somewhere, if anybody. But again, if you're talking about average human beings, there's only finite number of languages we can speak, and that's typically single digit. Linguistic power. Our vocabulary is going to be based on where we are speaking a language the most day after day, right? Whether we are speaking where we are almost every day at home, every day in school, every day at work, or what are the different places, or you're part of an academia, or your work is based on communicating with your clients. Your vocabulary is going to be based on how we are using it day over day, right? So again, linguistic power, not everybody would have the same kind of power. We would not remember all the words. The moment we start not using certain words, they would fade away from your vocabulary, right? So again, we're not so very good at kind of retaining everything all along unless you're using it over a period of time. Our generative abilities, a quick translation of stuff, right? Even if you know multiple languages, how good can we be in translating from one language to another, right? How fast can we do that? Again, we can do it, but again, think about whether we can do it for all language, for every sentence of one language to another language. Can we do that quickly? Can we do that? So again, speed, translation, vocabulary, coming up with fast all the words or different words. knowing multiple languages at the same time. We're not good with that, right? So again, there's limitations of human beings, and that's where we would want to kind of see if there could be a system and artificial system and automated system can really do this well, right? Then we are probably looking at a system or a future where, hey, we could have somebody with those abilities, then we can make that system work and do multiple tasks for you that could be very, very close to a human, right? That's what we can get to that point. But anyway, so what is natural language processing, right? Where does it stand? So again, it's one of those branches or part of, and you've seen this probably if you read the 3 chapters of O'Reilly book, and I've just I did steal this picture from that, but I wanted to bring it up here just to put it in the right perspective, and I hope you kind of remember that part. Like it's part of AI, and it is as old as AI as well. If you think, if artificial intelligence was first the term that was coined in or thought about um, as back in late 1940s and early 50s, then NLP is not too far behind that, or not too later than that, because when you think about intelligent machines, intelligence always has to do with how you're comprehending or understanding a certain command or language. So your intelligence would always need to have that ability to read or to listen or to say or speak, right? Those are the things, because that's when you're going to be able to do things in a more intelligent fashion. So again, NLP, again, hand in hand with AI, but it's really basically part of your AI, artificial intelligence, right? And comparing with machine learning is a plethora of all the algorithms, right? That's what machine learning is. And your deep learning is, again, you're taking all those algorithms. One of them, as you know, in neural networks, if you take that, multiple layers of those neural networks and apply more parameters, that's where you get your deep learning, right? That's where the deep learning is, and that's why it is part of that machine learning bubble, right? And there are kind of some of the things that kind of interrelate machine learning, NLP. You're using, certain machine learning algorithms for natural language processing, and that's why you see that they kind of intersecting in a way, but not too much. But yes, there is some connection, there is some relation there, there is some intersection there. So just putting in where NLP stands within AI. Okay. Now, going a little over history of NLP models, right? Where does it really start? And it starts back in multiple years. Again, we're talking 1950s and late 1950s or 60s, when we started with the rule-based NLP model. So yes, we started off long time back, and it took many years to see or to get to a point where we are today, which is the most exciting time of NLP. Never had this kind of an exciting time ever for NLP. Of course, except for when it all got started, right, with the rule-based, where based on certain rules and heuristics, you want to kind of understand the rule, the patterns, and to extract the information, or to kind of know what kind of information based on certain rule you will have certain response back, or which could lead to some decision making based on what you're reading, right, based on the rule that is being applied. So that's rule-based and heuristic-based models. Then came your statistical models, like hidden Markov, like your understanding the parts hidden, kind of a grammar within the sentences, like knowing the parts of speech. Then understanding the combination of words and how many times they're repeated within the document, and different types and different numbers of words, right? Like first take 2 words, how many times these 2 words are being repeated. Take 3 words, how many times these 3 words are being repeated. And based on that, you building that intelligence within the model to know how it can generate the next word, the next sentence in it. So that's where it all started. It all, I mean, this idea was there much many years back. So what you're seeing today in terms of all the things that are happening and making it exciting with the GPT and on all those large language models, the idea was there out there, and it was many years back. So, but we kind of evolved over time, and I think over time what you've seen is the computing has also changed. The way our machines, so like the computers back then to back today, or take it to fast forward it to today, has gone through an evolution that has also helped some of these areas to really grow and evolve. Then came machine learning, right? Machine learning, yes, that appeared to be one of the exciting times. Like if I had to say before today's world, what was the exciting time was when we were also taking the language and using some of our machine learning techniques that made things in and understand and make things get done in much more automated fashion, right? Turning your language into numerical form, and then using this power of machine learning algorithms. Like we use naive for text classification or support vector systems. Then came recurring neural networks, right? The networks that where in a recurring fashion you could have your neural units feed from one unit to into as an input to another unit, and so on in a sequential fashion. The RNNs that they are called. And because again, language is the sentence is sequence of words, right? They have to adhere to certain sequence, and they go from left to right. Same way your RNNs are also sequential models. Now again, one of the drawbacks, as you may have also read, was again the time consumption, and also the fact that they would lose out, like while you're going through and feeding one to another, it would lose track of where it all started, right? It would not have a memory of where it started, right? And that's when the LSTM, the long short-term memory RNNs, came into play and kind of helped out. But that was the time when sentiment analysis and text classification became more robust and more automated. And then, of course, with the social media data that was kind of coming into play at that time, right? All the social media platforms coming into play, that, having that machine learning techniques was really helping out, right? And it was kind of helping to build the sentiment analysis and all that the platforms needed, the online retailers needed for their products. So that was another exciting era, and which still continues. But then we'll get into the era of transformers, right? Those large language models. The transformers really, changed it in multiple ways. It is, again, one of the exciting times, and what has led to what you're seeing today. So 5-6 years back, and once again, this is all happening within the last few years. So transformers, like you think about BERT and Google's BERT, which kind of almost a revolutionary model, that the way that transformers were built, that made not just doing things sequentially, but in a parallel fashion. That parallel kind of, if you think about parallel computing change the computing world, this parallel kind of a processing of text in a way that this transformers do also revolutionize how, that we can really work on large corpus of text and build those large models that are not taking in few parameters, a few hundreds and few thousands of parameters. We're talking about billions of parameters. We're talking about more than, few hundreds of billion parameters that are fed, that can be now fed to these models, and these models being built here. So that's where your GPT has, kind of come up with if it started with BERT, it's now we are at, at the GPT level. Which is gaining, and it has really made this world so exciting that we are seeing things happen so fast. It has really helped revolutionize the generative AI world, the AI world in general. It has revolutionized the way we are having multi-model kind of, systems, where the system is not just about text and images. We are now kind of trying to combine text and speech and voice and text, and then again the other things that we can all kind of build together now, images. So bringing in all the power of all these different models together is where we are kind of headed to into this AI world. And that's why this AI all of a sudden has started to have that great momentum again. And we are seeing more AI kind of true AI kind of systems. Of course, we are not there yet 100%, but getting there in exciting times. Okay, so let me stop here. And I know went through I did a lot of talking in the last few slides, but any questions at this point, guys?
I don't have any.
Okay, already.
Yeah, neither do I. Yeah.
Okay, thanks, Jason. Thanks, Erin. Okay, so where are we with NLP today, right? We did, spell checking. We did, some of the easier tasks that some of our old models did. From spell checking to thinking, then to keyword-based information retrieval, to topic modeling, to text classification, to extraction, to having those chatbots only for doing certain tasks for a certain domain area, that you can only feed all those conversations, right? You feed all those conversations and run some of the machine learning and use machine learning techniques to make it better with doing conversation for a particular domain. So it was kind of a closed domain kind of an agent, to now seeing the summarization, the question answering, the translations, to seeing you kind of come up with any questions being asked and kind of answers being fed and all that, the ChatGPT kind of an era. So we kind of, at this point here, we are so much now into text summarization. So we are doing all those hard tasks that you can think of is what current era, the current era of these models, the current generation of models are now working on and trying to do and better and better and better. So that's what this whole NLP is, and this is where we are. And once again, exciting times. I don't know where this the GPT kind of large language models, where this is going to take to. Really thinking about where are we heading, right? Where we've already have we reached the the top here? Are we at the top of the peak here? Or we haven't even gone there yet. We are still at the base. Really don't know. So really looking forward to what could be next in this. But there's still a lot of research going on, a lot of things happening, very exciting, and kind of seeing now that all those, I would talk about a few of the startups that are kind of coming up, and the things that they're doing makes this, we're in a very exciting world. Let me tell you that, because of all the advances that we have done, especially in the NLP world these days. So now we talk about kind of, little change of gear a bit, but thinking about text processing techniques, going back to what you have learned now. You learned about, hey, when you get a text, you clean it up, you remove your stop words, you remove that and do this and do that and do stemming and do lemmatization. All that's good, but that's, again, it's not a given set of steps that you do like any other machine learning problem. There are things that would work. There are algorithms that would work for certain type of data. It will not work for certain type of data. There are techniques that would work for certain type of data that will not work for certain type of data. Same here in NLP. Just because you've learned all of that doesn't mean that you're given NLP, you will start, taking off everything. You will just strip off everything. You'll use lemmatization, you use stemming, and then you apply text classification. Are you getting the same, performance that you are expecting? Maybe not. Think about it. And that's why, and again, guys, whatever I'm using it as any pictures or anything that I'm talking about, if there is a source and if there's a larger article behind it, I'm going to put it in the slide here. So you don't have to take any notes. You don't have to capture screens. This is recorded anyway. But yes, there are some, I've put in the the sources there that you can really go and read about it, because we'll not get enough time to really go into much details. But my point is, if you look at this chart here, what is it is showing? It is showing that, the orange line is, the using an algorithm called fast text. The blue line is using the algorithm called, naive Bayes, right? Which you probably already know about. And what it is doing it is every step of text, like when it strips off first, it just uses the lower form of the text and saying, okay, nothing else but just the lower form, and try to run a text classification problem on this text and seeing how it did. And as you can see here, it is at a certain point, right? Whereas fast text is doing better than naive Bayes for most part, or towards the entire piece there. But again, they are at the lower point than the other, that you see there. So then you, after doing the lowercase on your text, you add punctuation to it, right? Maybe in fast text, it got little better. The performance got little better. In terms of naive Bayes, was pretty much the same. You added the stop words, you removed the stop words, not added, I'm sorry. You removed the stop words, right? So you have the lowercase, you did the punctuation removal, you did the stop words removal. What happened? Yes, the performance did increase a bit, right? For both the algorithms, again, the performance increased. Now, if you did the stemming, right? We did the stemming of the words, taking it to the root of the words. And what happened? Your performance really dived, right? As you can see, and it dived from where it was. And then lemmatization again brought it back up to, if you just did, instead of stemming, if you did lemmatization, it brought the performance back up. That was the last point there, the last dot for both the algorithms, right? But did it improve than doing the lowercase and the punctuation and stop words removal? No. So again, this is based on the data, guys. I don't want you to think that stemming and lemmatization is bad. No, please, okay? That's not the point here. The point I'm trying to make is that when you are applying all these different techniques, make sure you try to see if you are doing better, if your performance is getting better, or is it getting worse. And this is where you will have to really try this out before you can really come to a conclusion. Because once again, it's based on the quality of data, the type of data in hand, and the algorithm that you're using. Some of these techniques may or may not be really working for you. Okay. So that's why I just kind of changed the gears, because I did want to kind of make this point, because many a times, just because you know all those different techniques, that everybody applies all those techniques and it doesn't work. Okay. So anyway. All right. So so as I mentioned, there were some very interesting NLP startups, right? So I wanted to just spend a couple of minutes talking about those startups. So there's a startup called Cleview, which is based on what you're what it does is based on what you're trying to shop. It recognizes it has some basic intelligence based on the words that you put in and all that. It comes up with an instant site search for e-commerce stores. It tells you which e-commerce stores. It's a Finnish, I think it's from Finland, one of the startups here, but it's revolutionized how you would shop. It's not like going to an Amazon and buying something, or knowing that you would probably get in Amazon versus Target versus Walmart. It is kind of saying, hey, I want to buy this. Which is the best store? And I know there are other sites that kind of give you, it's like even Google kind of gives you some of those, like if you want to find the best price, all this like Priceline and all those kind of, many other websites are there. But this is like, revolutionized just based on what you're searching for. It just opens up, a huge, kind of, basket of e-commerce stores that, based on what you're looking for and particular pricing and all that, you can put in a lot of information, and it can come back and tell you which is the best store for you to go, right? So based on your preference, based on whatever you have provided as an input. So which is pretty cool. Desti is another site, which is, it is again it's a search and planning of travel on a mobile device. Once again, you'd say, well, we've done this 20 years, 30, many years back, people have come up with websites. This takes it to the next level. It is not about, hey, I want to go here, I want to go from here to here, and give me all the prices of the tickets and all that, and what are the hotels there. It takes it to the next level by providing, again, based on what you provide, what you more and more you provide as an input, it kind of does that kind of a searching for you. It does plan out your travel accordingly based on your choices. Hey, I love to travel by train. I love to, I hate going on flights, or I hate going on water, whatever. It takes into account your liking, your interest, the way you provide the input. It can come up with a beautiful plan for you that works for you, right, as an individual. Yumly, again, based on what you've been eating and what is your really taste, and what cuisines you like and all that, it can come up and answer the question, what you will eat tonight. So again, it's been creative, right? Because now you made the machines understand you better through the words that you would provide as an input. It starts to understand you better now. It knows, using certain words that you provided, it can now relate to a lot of things. Again, it's trying to be a little more intelligent. It has tried to close the gap on the ambiguity that you would provide. But by knowing that these words relate to certain things, it can probably answer you better as to what you would like. Insight engines, it helps you to build intelligent search agents or assistants to search data within your organization to get timely answers. Iriban is another. It takes in a structured data, unstructured data, sorry, like emails or instant messages and social media, all that is being used to provide structured answers and to make some intelligent decisions, right? They can make intelligent decisions for your company based on that, or get answers to certain things for your company based on what has been the chatter within the company, right? You want to get some questions answered based on the chatter. MindMail is again another startup that builds intelligent conversational interfaces for any applications or devices. Then there's Engine, which is designed to give you direct answer based on internet search. It says that, hey, you search, you ask for any question, there is something out there. There is somewhere there's an answer for you on the internet, and it brings that for you. It's not a search. It's not about, it's once again, there's a little difference between the search and this is asking a question, trying like a GPT way, right? But it's kind of saying, I can search the internet for you, right? Real time. I can see if I can find answer for you by looking throughout the web for that answer. So again, these are some of the startups that are, again, I do not work for them. I do not. This is an article that I read. Once again, it's in the source of this slide that you can find and read more about it. But I thought I would just bring it to you, to your attention as to how the NLP world, the advances in NLP has led to these startups, these companies do things, so creatively in such a different way. Okay. Then just on similar lines, what are all these different NLP examples, right? Then these are examples, once again, they may not be all completely recent, but again, because of the evolution of NLP in the recent times, it talks about, there's an example about a Livox app, which is a communication device for people with disabilities who cannot really, use, or maybe have their finger dexterity, or can communicate, or they can have a speech, all that. This is really one that can interpret a lot that you're trying to communicate. It's a beautiful app, and if you get a chance to do search on the web and look for this app, and it will give you a lot of information about it. Then there's another a tool that is being created, an app called Sign All, that converts sign language into text. How cool is that? A multimodal, right? It uses facial detection, facial recognition system, along with trying to interpret that and put it in a language form. So again, a beautiful way, we are getting into the multimodal kind of an environment where you see all these different things interacting with each other and making intelligent and building intelligent systems. Then there's Google Translate. Anyway, it doesn't need any introduction. It's there for a long time, but just wanted to bring it up. It's another way of like how Google does things faster. Like as we were saying, right? We have finite number of languages a human can learn, and there's only a finite, there's only there's a limitation on how fast we can translate from one to another. But again, with Google Translate, it's almost real time. And how many languages can it do? Like, almost multiple languages, hundreds of languages that it can really do that for. And then, aircraft maintenance, where this is another unique application that many of the aircraft companies are using, or for aircraft maintenance, where they're not just scanning through manuals for any kind of an error and this could be used even, real time when the pilots are talking to the towers for saying they have an instant problem. There should be a way to scan through the manuals, to scan through hundreds of issues that the pilots and the aircraft maintenance guys would have talked about a problem, and it is all stored and it can be all scanned in real time for instant answers. Think about like a jet in the sky that has got a machine failure and it needs an answer right away on how it can fix things, right? So again, a lot of a corpus of text and the ability to kind of translate it into something more meaningful that can be, maybe, mentioned to or talk to the pilot, right? And then you can convey that to anyone who's looking for that answer in real time almost. And then, predictive police work, right? Predicting crimes. Again, you'd be surprised, but I was also surprised that there are some states that are already applying it. There are states like California, Washington, South Carolina, Alabama, Arizona, Tennessee, New York, Illinois. These are all some of the states that are using some predictive policing, and identifying the motive in crimes, or identifying the times when crimes may happen based on certain things, certain situations, certain life events happening. They could kind of, do some predictive policing there. So how cool is that, right? And it's all happening around. So all these are some wonderful examples of how NLP is really helping in each of these cases. Or it could be one of the models within the multi-model kind of an system here. Okay. All right. Any questions so far? Getting to the end here. So, but yeah, just few more slides, guys, and we should be, going into a couple more slides and we'll get into the assignment. But any questions so far? Are we good? I hope you guys are tracking with me so far.
Yep, I'm good. Thank you.
Okay. So bias, right? Again, I just wanted to touch upon this because I know there's been a lot of very good discussion, and I thought I could not just, take this away from today's discussion. And I said, I do want to bring it up there. You mentioned about gender bias, right? In multiple ways, when you're thinking of cooking, you think of females, you talk of STEM, you talk of males, think of males. And there are all those stereotypes, right? All those gender biases that has kind of come up, like every time certain words or certain things are being talked about, certain professions are talked about, there's gender bias. There's minority and majority bias, like you can include racial discrimination here or a class bias here, what you would call, but that goes into when you think about immigration and your jobs and your travel, when you're trying to travel to certain places in certain class of the way the mode of travel that you're using, that time, and then the businesses, the kind of bias that would have. So you've seen it, right? You've talked about it. So I'm not going to into a lot of details here. There are other biases too. Like there's a bias about height, about the weight. You want your leader to be one of the tallest people. You'll see there are certain companies where you'll see why the leaders all really some very tall, certain, or maybe of a certain race, of a certain type, or of certain height, Or maybe there's, again, weight is another bias there, right? There's a lot of bias there. There's a lot of bias about people's profession, about people's status, what they're doing. Based on that, you kind of come up with and you have certain bias. How do you really eliminate bias, right? Again, I think one of your classmates did mention that if you're going to be just feeding your models with things that is going to, because you want to eliminate bias, because you want to mitigate the risk due to the bias, you try to feed your model with, again, whatever it can balance things out. Are you making the model see the reality, or is the data based on certain reality, right? Once again, yes, you do not want it biased, but again, you don't want to you don't want to also feed your model with something that is not existing, right? That is not a reality, right? But so how would you then, that this is something I've been kind of also thinking about while reading through your posting, and in a way I've been responding is, why can't we think about, in a way, like, instead of just augmenting data that could nullify the bias, why don't we then kind of try to see if we can break the stereotypes and set examples to mitigate and reduce bias over time? What I mean by that is, let's say if I have a lot of examples about STEM, right? And when it says about science and technology, and then if we have lots and lots of people with of maybe of a certain gender being represented in the data for STEM, why can't we have a realistic data which could be of a different gender? So if it was of males, maybe you have females with the STEM, right? And that's when you just breaking breaking the stereotypes in the real world too, right? If we are having folks who are really taking up professions, which is happening, right? So over a period of time, once you see that stereotypes, we are breaking stereotypes in real life, it gets automatically fed into those models that are going to be more and less biased over time, right? But again, I'm not saying you have to wait for another 20 years for certain bias to eliminate. I'm not saying that. We'll have to strike a balance, of course, but think about breaking stereotypes. Think about breaking those stereotypes, getting those real world data or input to these models, and then kind of seeing that it will start reducing the bias over time. Okay. Again, there are bias that you can reduce by implementing certain framework, right? A framework, and this is a AI risk management framework from NIST, and it says, it's a very simple framework, a governance model that is going to look into all and trying to understand what are all the and recognize the risk that are related to context, and you identify those risks right within your model, identify the bias within the model, measure them, right? What are these risks, and by analyzing them, tracking them, how dangerous they could be, how they could be leading to some decision making which is not going to be really healthy, not going to be good, right? By measuring them, and how you would want to manage this risk, right? Whether you just simply augment data that is so unrealistic, or you try to do something for it, right? How would you kind of manage that bias in a way that, again, you don't want to feed unreal world data to your model, because again, the decision making would be unreal as well, right? So you want to strike that good balance to see that your model is going to still be really realistic, right? So again, for everything, we want to say that we want to be unbiased, but there are certain things that still would remain biased because of the way things happen, and the way things that we do within this current world. But again, are we have to measure the bias, and measure that how good your model is going to be for decision making, and whether it's going to be realistic or not. So, which is going to then lead to a system that is going to be really a trustworthy AI system, right? Which is going to be safe, going to be secure and resilient, explainable and interpretable. Is your model going to be explainable? Are you going to be able to explain and interpret the results of that model? right? Are you really keeping up with the privacy of the data that is involved in this model? How fair is your model, right? Is there going to be an harmful bias or a realistic bias, right? Or a realistic bias is, once again, I'm not saying it's always good, but again, is it harmful, right? A bias. And is it, and in terms of accountability and transparency, are you keeping up with that, right? So making your model valid, reliable, trustworthy. Okay. So that's what you want to, anytime you're bringing up an NLP or an AI based system, whatever you'd call like even AI, like a larger AI kind of a system, you want to kind of come up with a governance thing, right? Governance model that's going to really help you kind of identify bias at all times and mitigate any risk due to that bias within your data. Okay. So here, just a list of all the popular NLP tools that you can think of. You have in AWS, you have in Azure, Cognitive Services, Comprehend in AWS, NLP API in Google Computing Platform. You have IBM Watson in IBM. You have NLP platform called Monkey Learn. This is, and the reason, and there's a reason why I'm kind of, having added like a non-cloud, but some of those platforms, which could be even cloud, but they are really very good and very popular NLP platforms like Monkey Learn or Alien or Python. And Python is still a classic, and some of those packages like NLTK, Spacey, and Gensim, these are all excellent packages, right? So which I'm sure some of, at least a couple you may have used from these, three of them. But, again, these are some very popular NLP tools. And some food for thought, again, how would you take your learning about NLP forward? And what is your plan to practice the knowledge and skills you have learned during this week? Start thinking about that, right? A lot of this would be coming in. And, as a matter of fact, very soon you would be going out, with this degree. And some of you could be working in NLP and AI world, which is so hot outside, right? It's just a lot of things are going on. And maybe you could be part of it. So how are you going to keep practicing this knowledge? How are you going to retain this knowledge? How are you going to take this forward? How are you going to research into, finding out examples, finding out text data that you can practice for skills? So start thinking on those lines and start researching, start looking for things on the internet, and I'm sure you'll be able to find more and more. And from the resources that you've got, try to dig in to see if there are some related resources as well. Okay. So before I go into assignment 1 and talk to you about it for another 5-10 minutes, any questions on whatever we have gone so far? I hope this was helpful, guys, and not, again, just a repeat of what you may have gone through or learned during this first week of the course.
I don't have any questions.
Okay. All righty.
Yeah,
Thank you.
neither do I. I'm just finishing up one last thing to submit. So I should have everything caught up within the next probably by tomorrow afternoon.
Okay. All right. So with that, going on to assignment 1. So you'll be using AWS Learning Lab. So one of the biggest assumption here, you got the email, you got the lab, to kind of which lab you'd be going in to do this work. And you were all invited. So I'm hoping that I've not heard from anyone not having or having an issue to get into the lab. You are provided 2 Python notebook files. There's exercise part 1, exercise part 2, and you are also provided a template document, a Word document, which you'll be using to capture your responses. So you need to execute both the exercise notebook files, and you've been given the point allocation is provided in detail in the rubric. So there are 2 notebooks, as I mentioned. The exercise part 1 is about the text cleaning and processing methods in them. And then the next one is about the vectorization methods. Basically, the 2 main methods. And some of you may have already, if you've already downloaded this assignment, maybe sometime back, maybe even beginning of this week, you may see 3 vectorization methods. So please do not be confused. I mean, yes, the 3 would be for bag of words, TF, and TF-IDF. We're cutting it down to 3 different methods. But even if you write for 2, which I've kind of changed the document and said, just give me for talk about these 2, right? The bag of words and TF, IDF, which kind of makes more sense to me. These are, TF and IDF. I don't want to kind of separate it. So you can just, this is based on these 2 main methods that you would talk about, and you would describe them correctly based on what you see in the code. And as far as the rubric goes, yeah, you have, you'll demonstrate that the exercise part 1 notebook is being run in SageMaker, that you did run that. You discuss the result and you discuss it and you'll kind of provide some verbiage on that. You describe the purpose of the notebook. You will explain each code chunk. You would explain the purpose of stop-word list and how stop-word lists are generally used. You demonstrate that exercise part 2 was also successfully uploaded and run in SageMaker. You'd write a description of what the notebook does. And again, explain each code chunk. And this should be approximately 1 page, even the previous one, just 1 page is for the description. Answer questions about vectorization and encoding methods. As I said, these 2 methods. Even if you do 3 which separately, like TF, IDF, and bag of words, that's fine too. I'm good with both, okay? But TF, IDF, definitely I want to see, and bag of words, I want to see that, okay? Answer, and then finally, deallocate resources and ending the lab, which should be, a freebie almost, right? Those points. So you want to kind of do that before you end your lab. So this is how your entire 150 points have been, distributed. Again, there are points for each step within this assignment. Okay. Any questions on the assignment? Okay, I'm assuming it is no. Any questions? Any other questions about your module 1? Again, any on the course itself? Any questions that you may have in mind? Okay.
Not that I can think of.
Thank you, Chase. Erin, you good too?
I'm good.
Okay, excellent, folks. So we can call it a wrap. I think we're pretty much on time. So just 3 minutes early, which is good. Happy to give you a couple of minutes back here, and hope good luck with the assignment and good luck with the material in week 2. Okay, we'll meet again and this live webinar 2 weeks from now, where we'll discuss about module 2. Okay, good night.
Good night.
Thank you. Bye.
Good night.
Good night.
Good night.
Bye.